And one of the studies that we were working on at the time was looking at body composition and brain volume. This one participant, we'll just call her Betty, she is the picture of the majority of 50-some-year-old women that we see today. She was a mom of 3. She had cycled through years of losing the same 10 to 20 pounds. The medical community had given the advice to eat less, exercise more, do Weight Watchers, continue to restrict your calories. When we imaged her brain looked like the beginning of an Alzheimer's brain. She pulled at a heartstring, and we failed her. We failed her. The medical community had failed her. She had done everything that she was told to do. She ate less, she exercised more, and in the process, over and over, year after year, she totally destroyed her skeletal muscle. Her body fat was easily 35% with very little skeletal muscle. She had issues with blood sugar regulation, insulin, triglycerides, all of the things that you would imagine were to happen. The thing is no one had given her any advice to improve her skeletal muscle, which is at the core of these issues. Skeletal muscle is just the focal point. To do resistance training and to improve the quality and nutrient density of her food with high quality proteins. And I feel that we just totally destroyed her life. And then I started to think, what is the one thing that all these sick patients have in common? And quite frankly, it wasn't obesity. It wasn't that they were overfat. These patients with dementia and these patients with other disease processes, what they had was they didn't have enough skeletal muscle. They had unhealthy skeletal muscle. And that's where muscle-centric medicine came from. I just wanted to share that because it really does piggyback to what you're saying is, number one, framing why is skeletal muscle so important? And we've completely missed the boat. And in fact, we don't even measure it directly, by the way. When you get a DEXA is body fat percentage. You're laughing because you know exactly what I'm talking about. And you can recognize that we've built a foundation of information and knowledge on the shoulders of things that are surrogate markers. And when you do that, inevitably, there is going to be a shift, a change in paradigm when we begin to directly measure this tissue, which is actually what is going to happen through something called a D3 creatine. It's a deuterated creatine. It's tagged creatine. We're going to take a pill and you're going to be able to see how much muscle mass you have. It's going to be a urinary test. You're going to be able to see how much muscle mass. And for the astute listener, you're going to think, we were talking about muscle mass and strength. The literature, the large body of literature would suggest that mass doesn't matter, which doesn't make any cognitive sense. The idea that skeletal mass doesn't matter, that it's all strength, that really it's about strength. And my argument would be, well, we haven't been measuring it directly. And what we're starting to see is as soon as we begin measuring skeletal muscle directly, then yes, there is a relationship between skeletal muscle mass and strength. And actually, the loss of skeletal muscle is more impactful than the gain of body fat as we age. The International Classification for Disease, which if you're a physician listening to this, you know that this is the ICD-10 code. Sarcopenia is the loss of skeletal muscle mass and function. It's believed to be about 1% per decade after 50 years. I believe that it is higher, and I believe that it starts much earlier. I believe it starts in your 30s if you are inactive, just like heart disease and Alzheimer's. The ICD-10 code for sarcopenia to recognize it as a disease was 2016. Tell me that isn't mind-blowing.
It didn't exist before the last few years.
It wasn't recognized as a disease. And I want to highlight something else, that if you look at the causes of mortality, so the number of deaths for, according to the CDC, you have the top causes of death: heart disease, cancer, accidents, stroke, chronic lower respiratory diseases, diabetes, Alzheimer's, etc. Nowhere on that list will you see loss of skeletal muscle or sarcopenia, as well as obesity. You don't even see that on the list. Skeletal muscle is directly related for all of those that I listed, if not the root cause.
So in some ways, just like Alzheimer's disease, is a loss of neurons in certain parts of the brain, the substantia nigra, these dopaminergic neurons in the brain. Would you characterize a lot of the chronic disease we have as a loss of muscle? And no one is really thinking about it this way. Like we're losing critical things for the body, just like neurons are critical. A brain, we're losing muscle with sarcopenia here.
I would say that when we think about what are the things that actually kill us from a metabolic perspective, the root cause is skeletal muscle. And again, there's many mechanisms, whether is it an insulin resistance? Is it ceramides? Is it a mitochondrial dysfunction? Is it a receptor issue? I mean, there could be a million different, you just Google, causes of, pathology in skeletal muscle. You'll find a million, right? I don't know if anyone has decided on what the overarching factor is. But one thing is for sure, it is the one tissue that you can do something about. An exercised, well-trained skeletal muscle is healthy skeletal muscle. When I think about the hallmarks of aging, I think about protein turnover and proteostasis. And I believe that we are not able to keep up with the lifestyle. So humans are largely domesticated. This is a Western disease. This is not a disease that I believe has to happen, by the way. What I believe is happening is twofold. Our nutrition as we age is totally off base. It starts young, habits start young. We do not keep up with our changing physiology. And the balance between exercise and movement and nutrition changes. When we're younger, again, you could have done bicep curls in college and you probably were eating some Twinkies or something else, and you were still able to put on muscle. Let's be frank. Okay. You were able to do all those things, whether you got eczema or psoriasis or whatever it is, you were able to do a lot of things that potentially wouldn't be healthy, and you still probably looked great. As individuals age, that wave of youth closes, the capacity to leverage the youthful hormones, to leverage the body's plasticity while the window never completely closes until it's over, the ability to push hard enough to stimulate that tissue becomes more challenging. I believe that we are under eating dietary protein. I believe that we are eating too low of a nutrient dense diet from an iron standpoint, from a B12 standpoint, from all these nutrients that we need. And we are not pushing our bodies hard enough. We are deeply domesticated. We talk about protein as if it's just one thing.
Yeah.
That it's a generic macronutrient. There's proteins, fats, and carbohydrates. But dietary protein is made up of 20 different amino acids, 9 of which are essential. The 9 essentials must be eaten. Your body cannot make them, and they all have diverse biological roles. And they're not interchangeable. To your point about plant and animal protein, you could look at the back of a label and a hemp burger or something could say it has 10 grams of dietary protein, but the leucine content is different. The methionine content is different. The tryptophan content, all of these, it's not going to be the same ratio. And to put it simply, the next phase of nutrition research is going to recognize these limiting amino acids. And the main ones are methionine, leucine, and lysine, and limiting to various degrees. That is going to be the next focal point. When you think about these individual amino acids, each of these individual amino acids are nutrients. But when you look at the back of a food label, it only lists 14, right? 14 vitamins and minerals. What about threonine, which is important for mucin production? Threonine, 75% of threonine will be utilized to make mucin production, which is responsible for the health of the lining of the gastrointestinal tract. Methionine, a lot of the vegan vegetarian diets are methionine deficient, mostly vegetarian or vegan diets. And that's important for 1-carbon metabolism. That's important. It's a precursor for cysteine and subsequent glutathione production, which is the master antioxidant. And what about taurine? There's some great papers that have just come out about taurine and aging. Taurine is also important for the eyes. Lysine for carnitine synthesis, fatty acid oxidation. The list goes on and on and on. What we can count on is when we hit the needs of skeletal muscle, the protein needs for skeletal muscle, then everything else falls into place. That would be 0.7 to 1 gram per pound ideal body weight. The current recommendation is 0.37 grams per pound. I'm 115 pounds. For me, that would be 45 grams of protein. That is the minimum to prevent deficiencies. That has not changed since 1968. And again, based on nitrogen balance studies, to my knowledge, there are no health outcomes for nitrogen balance, which, by the way, nitrogen balance was adopted from agriculture to how do we raise cattle with the lowest amount of protein needed and the highest amount of carbohydrates to do it cheaply and to not stunt growth. As we age, why do we need more protein? Because we do have to counterbalance whether it's anabolic resistance. Again, skeletal muscle is a nutrient sensing organ. It essentially senses the quality of the diet, particularly sensitive to amino acids. Of those amino acids, it's exquisitely sensitive to leucine. That efficiency can go down. I say can because I actually am in line with you in terms of we don't have a ton of data on highly exercised older adults. You still see data that talks about people being healthy and sedentary in the same sentence in the literature. There's no such thing as a healthy sedentary person. Skeletal muscle as a nutrient sensing organ, there is the potential for that nutrient, the efficiency to go down. The way in which you counterbalance that is by having a robust amount of high quality protein. I also want to mention that the RDA, which is the minimum to prevent deficiencies, was also based on high quality protein.
Mm-hmm.
Our plant-based friends, that means the average adult intake of protein is around 68 grams for women and maybe 90 grams for men. And that is not all from high quality proteins. There was also a proof of concept. I think it was a French group that showed that the lower the protein intake was across the board, the higher the amount needed to come from animal-based sources.
There's just so many benefits to eating animal protein. You mentioned taurine. I did a whole podcast where I talked about the unique nutrients found in animal foods, especially for longevity. Taurine has been studied across multiple species for longevity, and it's not found in plant foods at all. Now, the human body can make it, but it doesn't make enough. And there's clear benefits to supplementation. Well, it only occurs in meat. So how can meat not be beneficial for longevity in every sense of the word? And if you look at the longevity, quote, experts in the space or people who are high profile in the longevity space who are doing vegan diets, they're supplementing with creatine, they're supplementing with taurine, they're supplementing with things that occur only in animal foods that are clearly beneficial. And to me, this is just kind of a fool's errand. It's an intentional fool's errand, and it's good that they're experimenting. I just think that it doesn't make sense the way they're doing it.
We have a whole population to feed. When individuals are talking about longevity in that way, who does it ultimately affect? There are vulnerable populations that don't even get enough iron. I was just looking at the statistics this morning. There was a recent conference in the Netherlands, which Don went to, and they were talking about that a healthy diet was, quote, out of reach for almost 3.1 billion people, and that there are 122 million people pushed into hunger since 2019. 1.6 billion women of reproductive age and young children have micronutrient deficiencies worldwide. Okay. 1 in 2 preschool age children and 2 to 3 women of reproductive age worldwide have some kind of deficiency. One of the major deficiencies is iron and calcium. This idea that we should reduce our animal products for any number of reasons is grossly irresponsible. And the effect that it will have on vulnerable populations is dangerous. And when I say vulnerable populations, this idea of a meatless Monday, not only does it have almost no impact at all, because of course, even in the US, agricultural combined is about 9% versus industry, which is 80 some percent, industry, electricity, and transportation. If you really care about the environment, then you're looking there. You're not looking at the smokescreen of affecting our children. And once you affect a child, they can't necessarily recover in that way during their growth phase. And then the other aspect of that is I still see patients. I still see patients twice a week. And one of the most difficult things to change is to change a person's mindset and habits. if we ingrain upon the younger population, the younger generation, that they should go meatless because it's going to make them morally better and et cetera, you can just put it in however you want to. The invisible implications above and beyond nutritional create challenges because then they go on to have families.